We are now going to talk about climate change. It used to be called global warming, but it is more appropriate to refer to it as a climate change, or some people call it climate extremes, because we're looking at not just fast major changes to temperature, but also to rainfall, droughts and floods, ocean currents, wind patterns, the whole kit and caboodle. Now, the topic of climate change has been politicized, has been demonized, has been a litmus test for a string of other types of values and approaches to governing and the role of government, the role of our caring for the earth, the role of scientists in our society. It is a very complex issue, and we are going to hopefully peel away at the rhetoric and come forth with an idea of what the discussion is based upon. The effect of climate change is not severe enough at this point to make it seem urgent. And when things do not seem urgent, they are often put low priority. President Obama in 2013, his inaugural address, attempted to bring it to the forefront by saying we will respond to the threat of climate change, knowing that failure to do so would betray our children and future generations. We shall see what happens with that in the future. But different graphics on this page show the different impacts that are being seen. Is it open for debate? Well, if you ask some people, especially in certain parts of the country, they say yes. Up to 30% of Americans feel it is up to debate. However, let's look at the scientists. Climatologists, not proctologists, not people who are not involved in the study of climate. The climatologists survey showed that 97% of climate experts believe that climate change is real. And you know, this is the part that gets people very upset. Humans are playing a major role in causing it. The reason they get upset is it also means that humans should play a role in ameliorating it, reducing it. There's a very clear pattern of scientific evidence. And Lonnie Thompson, our very own National Medal of Science recipient, has said it isn't the facts that are issued here. It's how we humans assimilate those facts and then how we react to them. And if you look at how the public feels, it changes with the wind. Get it? If you look at it compared to other certain concepts, now the public opinion about climate change and our need to react and just whether it's happening, I guess, it does better than evolution. Believe it or not, 50% of the United States, people in the United States, do not believe in evolution. We don't do very well. We're just above Turkey at the bottom of Western countries. Well, and it's kind of funny because evolution does worse than believing in the supernatural. A full 65% of Americans say they believe in ghosts. So there we go. All right. Here's just a cute little cartoon. The frustration that many people feel about climate change, where people say, just for once, won't you show me some straightforward proof? And then they turn away. I think that Kim Knowlton, the senior scientist with National Science Foundation, put it well. No one is going to point to a hurricane, say Irene, and say, this is it. This is climate change is here. But what we're looking at, what we can say is that we're seeing the fingerprint of climate change this year, and that year refers to 2012. This is global temperatures in 2008 relative to the average many years ago, 1951 to 1980. And the problem with climate change is it's so complicated. It's not one-dimensional. It is not uniform. Look, at some places have even gotten cooler in the subsequent years. It is not constant. We're not just trumping up to higher and higher temperatures every year. It comes and it goes and up and down. Statistically, though, if you look through the noise, you can see it. So here's where we are. The debate is no longer whether it's happening or even whether human forces are contributing. The debate centers on projections into the future based upon these 4 different scenarios. How fast are the changes going to occur? How far they're going to occur? And here, one that really worries a number of people: are there tipping points beyond which the changes are uncontrollable, unrepairable, or cataclysmic? Now, this uncertainty, as I was saying before, is not humanity's friend. People are just so enjoy cherry picking and finding exceptions to the rule. And as we just came out of a very tumultuous economic times in this country, worrying about something that may be happening 30 years from now is not what people wanted to hear. Plus, scientists really stink at communicating. They often come off as really smarty pantses and don't get that they are supposed to be making it palatable to the audience. Here we are. This is things you'll start noticing if you are reading the paper or watching online, is more and more businesses, governments, communities are responding to climate change. For example, the Russian energy company Novatek is taking advantage of the polar ice cap melting. It's building a $20 billion liquefied natural gas plant so they can send gas to China. There have been 204 sea vessels going from Asia to Europe, taking advantage of these free lanes. And that's up from about 40 in 2012 and 4 in 2010. They used to have to use very robust ice cutting, nuclear powered ice cutting vessels to get through the same area. 2012 was, oh my goodness. You start noticing things like the weather models for the weathermen keep underestimating the temperature. Last year was an amazingly hot temperature. It demolished the previous record set in 1998 by a full degree. You'll notice sometimes people also are upset because climatologists talk about temperature increases in terms of tenths or hundredths of a degree. Well, this one was the full degree. And so you guys, nobody who's under 28 has lived through a month of global temperatures that fell below the 20th century average, because the last such month was 1985. The drought was very hard also. It engulfed 61% of the nation. It was comparable to the severe drought of the 1950s, but not quite as severe as the 1930s, which was exacerbated by very bad farming practices that allowed topsoil to blow away. So this begins our thought process, I hope, where we have to start thinking of how we are going to address climate changes so that it does not take us unaware. If you prepare, perhaps you are able to avoid the billions of dollars necessary to fix things after. And here is just different temperatures last year. Hottest ever. We keep going with this. It was a big deal. But the Earth's climate over time, it's changing. It's always done so. We've gone through 10 major ice ages, 40 minor ones. The last major ice age about 10,000 years ago, the Mastodons. And the last minor one was during the period of 1250 to 1850, the little ice age. And Along with these comes climate changes of a different sort. For example, this is during the time the Mayan culture collapsed. They had a humongous drought. And again, such a noisy background with the Earth doing its own thing, it's hard to detect the signal that any changes caused by humanity it's hard to detect any changes to our climate caused by humanity's increased release of greenhouse gases. Without question, mechanisms other than greenhouse gases concentrations are involved in these fluctuations in the climate. But the current warming trend is happening much faster than previous hot spells, and none of the forces that are usually the prime movers here, such as the variation of the sun's strength, are in sync with the recent changes. So what does cause changes in the Earth's climate naturally? Atmospheric composition, changes in the Earth's orbit. Believe it or not, there are certain things called Milankovitch cycles, and those are changes of our orbit around the sun, and these slight movements are enough to change our climate. Variations in solar output, impact of large meteorites, eruptions of supervolcanoes. Those guys put things into the air that reflects the energy from the sun. Short-term changes, everybody's heard of El Nino, El Niña, and ocean current and circular patterns. These are very, very intense in their impact on the weather and the climate of local areas. Let's talk about the greenhouse effect. So how hot should the Earth, and let's just look at Venus as somebody who is away from the sun, closer to the sun, and how hot should they be based upon that distance from the sun? Well, the Earth's average should be about 0. Venus should be about 212. And the Earth right now is an average temperature of 59 degrees. Its atmosphere is water and CO2. That's what I'm looking at is greenhouse gases. And Venus has about 90% CO2 and 90 times the pressure that we do. And they see the effect as an average of 840. All right, so what I'm getting at is the gases have a lot to do with the temperatures. CO2 boosts heat. Concentration of CO2 has increased dramatically since the industrial age, when they started burning fossil fuels and putting CO2 out into the air, and it has not remained constant. Okay, yeah, of course they're related. All right, so the greenhouse effect. Our atmosphere traps and returns a major portion of the heat radiating from the Earth. The interesting thing about the greenhouse effect is that if you think of yourself in a greenhouse, the high energy rays of light from the sun come in and are absorbed by the surfaces and then re-released. And if there are particles in the air that can absorb this, then the air stays warm. Water is a fabulous greenhouse gas, and it is able to absorb a huge amount of infrared heat and then re-release it to the surroundings of the molecules. That's why it's warm in the evenings in the tropics, where it's nice and humid, and it's pretty darn cold in the desert, where there is very low humidity, very low concentrations of greenhouse gases. So the greenhouse effect, our atmosphere traps these. Well, let's take a look at this now. All right, so come in here. All right, so the sun brings us energy, 100%. 23% is absorbed in the atmosphere, 46% absorbed by the Earth. Now 25 is reflected from the atmosphere, and just a minor is reflected back into the outer space by the surface. Okay, so now let's take this 46% absorbed let's go over here. All right, so this is going to be re-released. It's emitted from the surface, 9% escapes, and 37% is absorbed in the atmosphere, and then 60% is emitted from the atmosphere. So what do we have? Of the incoming solar radiation, about 25% is reflected back. About 25% is absorbed by the atmosphere. And about 46 to 50%, let's just say 50% is absorbed by the Earth. Of this material absorbed by the Earth, when it is re-released, 37% is absorbed by our atmosphere. You have 37% of 46%, that becomes 80%. So the reabsorption of this heat coming from the Earth is 80% thanks to the greenhouse gases. Earth's energy balance. The greenhouse effect, that's what I was just talking about. About 80% of the energy radiated from the surface is trapped, absorbed by the atmosphere. Greenhouse gases. Well, greenhouse gases is down. Okay. Greenhouse gases are molecules that absorb infrared energy and release it slowly to the surrounding atmosphere. What are some greenhouse gases? Well, by far the most greatest amounts, water. Then we've got CO2. We have methane. It's a greenhouse gas. The freons, the materials that used to be in air conditioners and refrigerators, are also wonderful greenhouse gases. And lesser known, SF6, and ozone. The enhanced greenhouse effect is kind of what we're experiencing now. We're seeing an energy return greater than 80%, and this idea has been around for a long time, that the fact that an increase in terrestrial temperature is to be expected if you have a higher amount of greenhouse effect in the surrounding atmosphere.